This is tutoring for intermediate algebra at Raritan Valley Community College. This is going to be test 3 review, the content that's covered in this exam. So sections 8.1 through 8.3, 8.5, sections 10.1 through 10.4, and sections 10.6 and 10.7. So Chapter 8 topics, 8.1, what are functions? 8.2, identifying linear functions. Is a function linear or not? Section 8.3 is compound inequalities. And section 8.5 is absolute value equations and inequalities. And chapter 10 topics are 10.1 radical expressions, 10.2 rational exponents, 10.3 simplifying radical expressions, 10.4 operations with radicals and expressions, 10.6 equations with radical expressions, and 10.7 complex numbers. So 8.1 functions. Well, first off, one important thing is y equals f of x, meaning that that's the notation we generally use, f of x, because if we have two or more functions graphed on the same plane, and you call them all y, it gets a little confusing. So when we see f of x, that means f of x, y is a function of x. So we know if a relation is a function or not if for every one input you put in for x, there's one output for y. However, if you input one x value and it spits out two or more y output values, then it is not a function. So, for example, I have the function f of x equals 3x minus 1. So I would say I chose the x value 4. F of 4, I plug in 4 for every x. So f of 4 is going to equal 3 times 4 minus 1, which is 12 minus 1, which is 11. So f of 4 equals 11. So that one input x value I put in was 4, and it spit out an output of y equals 11. And no matter what x value I plug in here, I'm always going to get one y output. So therefore, it is definitely a function. So section 8.2, identifying linear function. Is a function linear or not? Well, if they give us a graph, how can we tell? Well, first off, what is linear? It's a line. So if it's a linear function, it has to be a line. So if we look at the function here on the left, that's not a line. It's got, curves and all that, so it can't be a line. So this is clearly not linear. This, however, is a line. So that means it is linear. Now, sometimes, they might just give you a function. How do you tell if it's linear or not? Well, first of all, we have this function, f of x equals negative 4x plus 5. Well, it's a first degree function because it's x to the first power, or x, and it's in slope-intercept form, y equals mx plus b. So that means it has to be linear. And this function here, f of x equals the square root of x, well, that's not linear because it's a radical. So if it's square root of x, there's no way it could be linear. And also, quick note, these two functions are not the graphs of either one of these. So this graph and these two functions are all separate from one another. Now 8.3 is compound inequalities. That's where we have inequalities to have and or. So if we look at the two examples here, when you have an and, that means it includes both. So you have to include solutions for both on it when you graph it on a number line. If it's or, well, then you don't include both sets of solutions, meaning that it can be either or. They're exclusive from one another. Now 8.5, absolute value equations and inequalities. So we have an absolute value equation. Absolute value of 12x minus 24 is equal to 24. And here we have an absolute value inequality where it's the absolute value of 5 minus 3x is greater than 3. So just like linear inequalities and linear equations, except it's just absolute value with it. Now we go into chapter 10. 10.1 is radical expressions. So, for example, you have, square root of 4 is 2. Why? Because Well, what number or term times itself gives you 4? 2. 2 times 2 is 4. And then here, square root of 9x squared is 3x, because 3x times itself is 3x. Cubed root of negative 64 is negative 4, because negative 4 times itself 3 times is just going to give you negative 64. Now, 10.2, we go into rational exponents. So a rational exponent is where you have an exponent that's a fraction. So, for example, we have x is equal to p over r. And the way you would write that in radical form, it's the r through of x to the p power, where p over r is equal to power over root. I know most textbooks don't show it that way, but that's the way I always like to teach it because it's a good way to remember it. Mnemonic device, p over r, p for power, r for root. So it's power divided by root. So for example, with the second one here, 17 to the 1/2 power. Well, the power here is 1, and the root is 2. So it's going to be 17 to the first power, which is 17, and then root 2 is just a square root. So it's square root of 17. Now we go look at this, 8 to the 2/3 power. Well, 8 to the power of 2, that's 8 squared, and then the third root, or cubed root of it. So it's the cubed root of 8 squared. Now, the next video I make, we'll go more into simplifying and so on. This is just the content, just to reiterate. 10.3, simplifying radical expressions. So this is also very important. So this is one of the most fundamental principles of multiplying radicals. Square root of a times square root of b is square root of ab. So what happens is, anytime you're multiplying radicals that are alike, you multiply what's underneath, but the radical stays. So here, a times b is ab, the radical stays. Same thing here. Okay, cubed root of c times cubed root of d, they both have the same root of a cubed root. Multiply c and d is cd, and the cubed root is cd. Here, the nth root of x times the nth root of y. Well, it's just going to be x times y, which is xy, the nth root of it. So that's the basic principle. Now again, these have to be the same. So if I have, cubed root of x times the 5th root of y, I can't multiply those together because one is a cubed root, one is a 5th root. They're two different roots, so the roots have to be the same. Always remember that. Now 10.4, we're going to talk about operations with radical expressions. So you can only combine like radicals. So think about it in general with combining like terms. You can't add, you can add x with x, but you can't add x with y, okay? So for example, if I have 2 square root of 3 plus square root of 3, both of these guys have square root of 3 in them. So I can add them. So my final term is going to have to be square root of 3. I have 2 here and then 1 here. 2 plus 1 is 3, so 3 square root of 3. And then we skip over to 10.4, equations with radical expressions. So what this is sometimes we have equations that have radical expressions, or you have radical expressions with linear terms or other type terms. So if we look at the examples here, square root of x plus 2 is equal to x. Then we have square root of 2x minus 1 is equal to square root of x plus 3. And then here we have square root of x plus 1 equal to square root of x plus 2. These are various types you'll come across. Again, in the next video, we'll go more into detail about how to solve them, so on and so forth. And the last topic, 10.7, complex numbers, which is actually a personal favorite of mine, complex numbers and so forth. So square root of negative numbers are imaginary, because if I had the square root of a negative number, what number times itself gives you that number? There's nothing. So for example, if I'm trying to find the square root of, say, negative 1, well, there's no number times itself that can give me negative 1, because 1 times 1 is 1. That's not negative 1. And negative 1 times negative 1 is also 1. So that doesn't work. So the square root of negative 1 is I. I is for imaginary. And then these 4 principles here are very important. I is equal to I. I squared is equal to negative 1. I cubed is negative I. Why? Because if I take I times I squared, that's I to the 3rd. And I times negative 1 is negative I. And then I to the 4th is 1. Why? Well, if I have I squared and I times it by itself or raise it to the 2nd power, That gives me out of the fourth, which is equal to -1 squared, which is just 1. So this is all the content for test 3 in intermediate algebra at Raritan Valley Community College. So I hope the explanations help, and we'll see you next time. Bye-bye.